All right, let's talk about adding, subtracting, and multiplying matrices. We won't talk about dividing matrices because you don't divide by matrices or divide with matrices. We have something else that we do. But first we're going to talk about adding and subtracting. And to add and subtract, you need to have matrices that are the same size. Now when we give the size of a matrix, we always give it as row by column. And so if you look at this first matrix, for example, matrix A, it has 2 rows and 2 columns, so it's a 2 by 2. Matrix B doesn't look like it has any rows, but it does. It has 1, 2, 3 rows and 1 column, so it's a 3 by 1. Matrix C has 2 rows and 3 columns, so it's a 2 by 3. And then matrix D has 3 rows and 3 columns, so it's a 3 by 3. Now, like I said, when we add and subtract matrices, they need to be the same size. We don't have any that have the same dimensions. I'm going to pick, though, matrix C, 1, 4, -8, -3, 0, and 9. And we're going to add another matrix that I just make up. 2, 7, -6, -8, 3, and -4. We're going to add these two matrices. Now, when you add two matrices, you just add the members that are in the same place. So, for example, 1 plus 2 is 3, 4 plus 7 is 11, -8 plus -6 is -14, -3 plus -8 is -11, 0 plus 3 is 3, and 9 minus 4 is 5. And there's my resulting matrix. Now you can also multiply a matrix by a scalar. So let's take my C matrix, 1, 4, -8, -3, 0, 9, and let's multiply it by -4. When I do that, then I multiply every member by -4. So I get -4 times 1 is -4, -4 times 4 is -16, -4 times -8 is +32, -4 times -3 is 12, -4 times 0 is 0, -4 times 9 is -36. All right, so now that we know how to multiply by scalars and add matrices, we're going to solve a simple matrix equation. Now this matrix equation is going to have 3 by 2 sized matrices in it, and I'll show you how that works. It's pretty fun. So here's my sample matrix equation. So we have 2 times the matrix -2, 1, 3, 9, 6, -11, minus 4x, -1, y, z, -5, and that equals -8, -6, 7, 7, 5, -17. All right, and when I look at this matrix equation, I've got a scalar, I've got a minus. I'm going to work with that first. I'm going to multiply this matrix times the scalar and this matrix times the negative sign so that I can add instead of subtract. So this matrix becomes 2 times -2 is -4, 2 times 1 is 2, 2 times 3 is 6, 2 times 9 is 18, 2 times 6 is 12, and 2 times -11 is -22. Over here, I'm adding, and I'm just going to make each one of these terms the negative of what it already is. So this will be -4, -x, +1, -y, -z, +5. I just distributed that negative sign to every member of that matrix. And then that equals -8, -6, 7, 7, 5, -17. All right, well you can see that -4 plus -4 is -8. That's a true statement. 6 plus 1 is 7. That's a true statement. But here's a statement that has a variable. 2 plus -x equals -6. So 2 minus x equals -6. And I'm going to solve that for x. So I'll just add x to both sides. And I have 2 equals x minus 6. I add 6 to both sides, and I get that x equals 8. All right, well, let's look at another one. 18 plus -y equals 7. So 18 minus y equals 7. Here again, I'll add y to both sides. And then I have 18 equals 7 plus y, subtract 7, and I get that 11 equals y. And then, of course, I have one more variable, so I'll write that equation. 12 minus z, remember I'm just looking at the terms that are in that lower left corner, equals 5. Add z to both sides, and I get that 12 equals 5 plus z, subtract 5, and z equals 7. So that's a simple matrix equation. All right, but let's talk about multiplying matrices, because multiplying matrices tends to be the hardest thing for students, especially students who are just learning. And one of the things that you have to keep in mind when you're multiplying matrices, you can't multiply just any two matrices. They have to have the first, the number of rows of the second matrix has to match the number of columns of the first matrix. So, for example, I cannot multiply B times C because 3 times 1, 2 times 3, the 2 and the 1 are not the same number. So that won't work. The number, so if you write it this way, R1 times C1, R2 times C2, number of columns of the first matrix have to equal the number of rows of the second matrix. All right, that doesn't work. But I can multiply C times B. 2 times 3, that's what C is. B is 3 times 1. I can do that because those 3's are the same. All right, so there is no commutative property for multiplying matrices. Multiplication of a matrix is not commutative. All right, now for the sake of time, what we're going to do is we're going to do matrix C times D, because I want to show you something that has a few more elements in it so that maybe you can establish a rhythm as you go through here. So there's matrix C. I want to multiply by matrix D. All right. Now when you multiply two matrices, you're going to multiply the row of the first one times the column of the second one. All right. So this first row times this first column gives me 1 times negative 1 plus 4 times 2 plus, and then negative 8 times 5. That gives me one number in my final matrix. All right. Now I take this row and I multiply it by the second column. So 1 times negative 3 plus 4 times 6 plus negative 8 times negative 2. All right, there's my second number in my matrix. Now I'll take the first row and multiply by the last column. So 1 times 0, and then 4 times 7, and then negative 8 times 1. I'm adding all of those. So there are my first 3 terms in my matrix. All right. Now, to get my next answers, I take my second row and multiply by each one of these columns. So my second row times this first column gives me negative 3 times negative 1 plus 0 times 2 plus 9 times 5. And then my second, now to get my second number, I take that row times the second column. So negative 3 times negative 3 plus 0 times 6 plus 9 times negative 2. And then for my last entry in my answer matrix, this row times this column. So negative 3 times 0 plus 0 times 7 plus 9 times 1. All right, so my final matrix answer is going to be negative 1 plus 8, which is 7, and then minus 40. So 40 minus 7 is 33. That's a negative 33. Then negative 3 plus 24 is 21. And then plus 16 is 37. And then 0 plus 28 is 28. Minus 8 is 20. And there are my first 3 numbers. Here we have negative 3 times negative 1 is 3. Plus 0 plus 45 is 48. Here we have 9 plus 0 minus 18 is negative 9. And then 0 plus 0 plus 9 is positive 9. And there is my answer matrix. You will notice that your answer matrix, or in this case, our answer matrix is 2 rows by 3 columns. And if you look, then when we multiplied C times D, 2 by 3, 3 by 3, remember these two numbers have to be the same. Well, look, my answer matrix has the same dimensions as these outside numbers here.